Okay, this is lesson 113, symmetry of solids and polyhedra. So we're going to talk through what plane symmetry is, and we're then going to talk about what symmetry about an axis is. So first, plane symmetry describes a 3D solid, such as the ones that we're looking at right here, that can be divided into two congruent, remember that means equal, so two equal reflected halves by a plane. So you'll notice with plane symmetry, I could cut it, see this blade right here or this sheet of paper? That's two congruent halves that are reflected. I could have also gone horizontally, couldn't I have? So there's more than one way to create plane symmetry. Then there's symmetry about an axis. Another way to say that is rotational symmetry. So this one up here is reflection, and this one's rotational, okay? And this describes a figure or solid, again 3D, that can be rotated about a line, and that line is called the axis of symmetry. And the image coincides with the pre-image. So if you're looking over here, if you rotate it clockwise about this axis, you can rotate it twice because it'll turn horizontally, right? And then it'll turn right back up vertically. So it's got an order of 2. Later on, we'll go into that more. All right, so for this first example, it says, for each figure, sketch one plane through the solid, so these two right here, that will divide it into two congruent reflected halves. So do that for me. Draw a line through each of those shapes, those figures, that will divide it into two equal halves. Okay, so you might have drawn something like this, or you could have gone horizontally as well. Same thing with the triangular prism. You could have gone vertical, right? It's still reflected and it's congruent. Or you could have gone horizontal. Super simple. Now, down here, it says determine whether each solid has rotational symmetry. Remember, another word for that is symmetry about an axis. Over the axis shown. If so, give the order and the angle of rotational symmetry. So, look over here real quick. You see this cube? They drew an axis of symmetry going diagonal. And so, if I were to look at these arrows, right? It always ends up being 360 because it's a full circle. So the way you find the angle of rotational symmetry is you take 360 divided by 4, write this down. That's how you get the 90 degrees. So that right there is the angle of rotational, and I just use the angle symbol, rotational symmetry. So angle of rotational symmetry, 90 degrees. Now the order, write this down, the order of symmetry is 4. So we've got the rotate angle and we've got the order. And the reason it's 4 is because I can spin this 4 times to land back where I was. Okay, so let's do another one together and then you'll do B on your own. All right. So, how many sides do you see on this pentagonal prism? 5. So we're going to take 360 and we're going to divide by 5 and tell me what we get. Very good. So it has a 72-degree angle of rotational symmetry. How many times do you think I can spin this or rotate it to get back where I was originally? 5. Yes. 5 times. So the order of rotational symmetry is 5. All right, you try to do example B. Okay, Logan, how did you get the angle of rotational symmetry?
I did 360 divided by 9.
9. Is that what y'all got?
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8.
Wait. Oh, I counted it.
It's okay. Thomas, did you put 9 as well?
Be 45.
It would be 45. 45 degrees is our angle of rotational symmetry.
So then the order is 8.
Exactly. The order is also 8. Y'all are counting it again just to be sure. All right, moving on. Last part of this lesson says, draw 2 planes through the figure that will divide it into symmetrical halves. So let's start with that. I can draw it like this. Would y'all agree that that's half?
Mm-hmm.
But I could also draw it like that. Isn't that 2 congruent halves that are reflected? So there's 2 ways I could do that. It says then draw an axis through which it has rotational symmetry and give the angle and order. All right, so the rotational is very specific though. It's got to be through here. And again, we're rotating it around. There's 2 halves, so we will take 360, divide it by 2. Tell me what you get.
180.
180. There's my angle of rotational symmetry. And they want the order. So if there's 2 halves, our order is 2. Because it spins once and then spins again and then back to where it was. Okay. Lesson 114 is a review from Algebra 1.
Uh-oh. Algebra 1.
The tail end of it.
Like 3 years ago.
I know. It'll all come back to you, watch.
Is this y equals mx plus b?
It is. Good observation, Harper. She said, is it y equals mx plus b?
Oh, yeah, that thing.
So we are going to be graphing, and I'm going to graph this one in purple and then this one in red because you want to see 2 different lines. So get out colored pens if you have them.
Wait, Miss Davis, if like, because 4, that would be the like point where you first put on the dot, right, on the line. Because that's
Yes,
B.
very
And then
good.
if X is just by itself, then X, the rise over run is 1 over 1, right?
Good memory.
And you just go up, down, over 1,
You
and
shade
down
it.
1 over 1.
Oh my goodness,
Oh,
y'all
this is
are
so easy.
really rocking
I
this.
kind of remember these. I
Okay,
like
good.
them.
I like these too. They're fun to me. See,
They're
look
kind
at
of
all my
easy,
colors.
Yeah.
Okay, so like Thomas said, we're going to start at the 4 on the y-axis. So 4, put a dot, and it says to go up 1 over 1, right? First of all, I want to review with you. Did you know that when there's not a number in front, there's an imaginary 1? Okay, so we're going to go up 1 over 1 in a positive direction. So watch me. Up 1 over 1, up 1 over. So we're going to plot this with a positive slope. You may want to use a straight edge, something to draw a straight line, like I used this. And then you ask yourself, should I do a solid line or a dashed line? Solid. How do you know that?
Because it has the little line at the bottom.
Yes, it has the equal to. Sorry, my line's not right. All right. Now time to graph the red line, which shows at -1 is my y-intercept. What's my slope?
2/1.
Okay, so up 2/1 in a positive or negative?
Positive.
Okay, so go up 2/1 in a positive direction, however many you want to do. Should I do a solid or a dashed?
Dash.
Yes, dashed because there's no equal to. Okay, now time for the shading. So I'm going to use yellow for my purple. Should I shade above or below the first line? Below, because it said less than. So I'm going to shade below the purple line. Now let me pick a different color. Should I shade above or below my red line, my second line? Above. So I'm going to shade above that line. Okay, my answer, guys, is where they intersect. So that murky pink right there,
Is it 5?
that is the answer. That's your final answer. This right here.
Oh, should we just draw it?
This one. You just.
That's
just
just-
That's your answer. Mm-hmm.
So you just
So whenever I'm checking your work, I'm looking for the darkened shading. Because that tells me that you know where the region lies for the answers that are possible solutions. So what this means is any ordered pair that falls in here is true. It's a solution. Anything outside of here, these are not answers to the questions. Because these are inequalities, there's lots of possible answers. You just have to pick the region that has the answers included, which is this right here. It sounds like this has already come back to you guys.
That's pretty easy.
Yeah, I agree. Should I do one more with you, or you think you got it?
We got it.
I think so too. Okay, y'all, try them.
Plus 1, so you go plus 1 is going to be. So that's not -1. Because it's -1. So you go this way.
Yes, what I did. Went this way down, this way down, this way down, this way down, this way down.
Look, that's not positive direction, that's a negative direction.
So let's go what?
So you just go.
Oh, because
Right. Because that's in a negative direction.
you're right,
it's
you're right,
negative.
you're right, you're right.
So
Should I do 3
Mm-hmm. 4 is the only one that is a little
tricky?
tricky, but I think after I show y'all how to set it up with two equations, or sorry, two inequalities, y'all are going to be good to go.
For 3, there's no x though. You just do.
Okay,
it's
so
just y negative 2.
It's that straight line, yeah.
Okay, now I remember.
Yeah. No, I don't think it's like that.
Mrs. Davis, can you do number 2?
Yes, most definitely. Okay.
Yeah, I have the X. I just don't know if you
It has to be like that.
All right. So I will do the first one again in purple and the second one in red again.
The answer's one.
Okay.
Yeah, answer's 1.
So -1, that's my first y-intercept. And I'm going up 1 over 1 in a positive direction. So like this. And it's a dashed line because there's no underline. And then I'll switch to my red pen. It says that it's at +1. Is that what y'all got?
Yeah.
This one's a negative slope. So we're going to go in a negative direction. This one is also dashed. Now time for the shading. For my first line, it says to shade below because it's less than, right? And then for the other line, it says to shade above because it's greater than. So my final answer is there. How was that? Is that what y'all got?
Yeah,
I could say.
in a way.
In a way. What part of that did you not get? Meaning, was it the dash solid, the shading?
The whole, like, purple line, I shaded all above it.
Honestly, I
Mm.
had no idea about the shading. Can
And
you
then-
do that again?
Purple,
Sure.
I shaded below it. So, like, I had everything, it's just you left, like, a square off that I didn't shade.
Okay, well, let's look at it. So this right here
Uh-huh.
says I better shade where the Y's are smaller than that line. So look at my purple. The Y's are smaller down here than they are up here. So if it says Y's are smaller than the purple line, I better shade
Down.
That's what I
down.
did.
Okay, good, good,
And then
good,
the other
good.
one is the Y's are greater, so you
Yes.
need to shade up.
Exactly. So like
Okay.
Thomas said, Y's are more. So look at the red line. Well, the Y's are more from here up of the red line. So that means I shade everything above the red line. Oops, sorry.
About to say.
Oh my gosh, I was on the wrong one. Above the red line.
Well, why wouldn't you shade the others? Oh, never mind, I see now.
Yes. And so because green and yellow overlapped right here, this is my answer. Not this, definitely, not this, but this region is my answer. And y'all are going to see a lot of this in college algebra. They love teaching this in college algebra, so no sense in forgetting it yet.
Three. Can you do the first part of 3
Absolutely.
with like the 2
Yes.
Y's? Oh, I forgot this part.
Isn't the first part just x minus?
No, it doesn't have
Can you
an
see
X.
if I did this equation right? If I wrote it right?
Just throw it in there.
Let me compare it with mine.
I.
Oh,
I
you're just
erased
missing
that.
your
It's gonna be
X.
one
I erased
what?
it because I just thought it was 2.
Unless-
And then just erase that too.
Because it's just burned.
Mm-hmm. And then you're ready to go.
See, I don't think so.
No, not at all. All right, so y'all said number 3, right?
Yes.
Okay, so let me get my colored pens out again. Purple will be, oh wait, we have 3 now. So I'll just, oops, I'll have to use blue
Wait,
as well.
doesn't it go together?
No, there's a comma there.
Oh, okay. Oh, yeah.
So we're going to graph that purple one, y is greater than equal to -2, as if it said y equals -2. So in other words, you find the -2 on the y-axis, so right here, and you go straight through it.
Oh.
Yeah. And it's solid because it's an equal to.
We should know that.
All right, time to graph the red line, which says +1 on the y, and go up 3 over 1 in a positive direction. So 1, 2, 3 over 1, 1, 2, 3 over 1. It looks like it too is solid. Okay, and then the last line starts at 6, and it is a negative slope down to over 1, and it too is solid. Are y'all still with me?
Mm-hmm.
All right, time for the shading. Let me get out my yellow highlighter for purple, which says to shade above that, above the purple line. Let me get out my green,
Wait, and why is it above again?
because it says y is more than.
Oh, yeah.
Okay.
Greater than or equal to.
And then the next one says y is less than my red line. Y is less than my red line. And then I'll get my blue out. It says that y is smaller than my blue line. So smaller than the blue line. And you'll see that my answer is right in this triangle. That's the only spot where all three of them overlap. I need all three colors, the yellow, the green, and the blue, which is that pink triangle smack dab in the middle. Okay, I really want to work this word problem one with you because they don't give you the equations. So it says here that Leslie's age is equal to or less than, you hear that talk? Less than or equal to? Twice Bruno's age. So I want you to first designate x, y variables. So we'll make Bruno x and Leslie y. So if Leslie's age, so let's do y for Leslie. If Leslie's age is less than or equal to twice Bruno, that's our very first inequality. Now we need at least one more. It says, and greater than or equal to Bruno's age plus 3. How would we do that?
The other way?
So greater than or equal to Bruno plus 3. All right, here you go. These are the two inequalities that I want you
And if there's not one
to
there
graph.
for the y-intercept, it's 0, right?
Yes.
Yeah.
Like Thomas said, if you don't see a y-intercept, it's assumed to be 0.
Why wouldn't it be 2x for that one? As for the-
Because the next part says greater than or equal to Bruno's age plus 3.
So it's not just twice Bruno's age, it's just
Right. Because just look at it this way. This part goes with the first inequality, and then this part goes with the second.
Okay.
Because I think you were maybe wanting to combine both.
Yeah. Okay. These are easy lessons today.
Yeah, isn't that wonderful?
I hope the last one will be good.
It's not hard if you can remember all your formulas.
shade?
Okay, let's look. 0 and up to over 1. Okay, so remember, we start at 0 because they didn't give us a y-intercept, so it's assumed to be 0. We're going to go up to over 1 in a positive direction, and it's going to be a solid line because it's equal to. And then for my next line, we're going to start at 3 on the y-intercept, and we're going to go up 1 over 1 in a positive direction. And that one, too, is solid because of the equal to. All right. For the purple line, which is my first one, it says y is less than. So we're going to shade below the purple line. But for the other one, it says greater than. So I got to shade above my red line. So this small little sliver right in there, that's the region. Anything that falls in here would qualify. That would be a possibility of Leslie and Bruno's age. Okay, but nothing out here. Any coordinate that falls out here could not work for Leslie and Bruno's age. All right, any questions before we move on to the last lesson of the day? Okay, just be careful with your shading, your dashed, your solid, all the things that go into it. Okay, last lesson. It's lesson 115, finding surface area and volumes of composite solids. Now remember, composite means when you put a bunch together. So we're used to solids that are isolated, so like a cylinder or a cone. But when you put them together, you end up with this composite figure here. Now, there's something called common faces, which means they share it. So you see how there's a hidden base right there? When you're finding surface area, you would not add that into your solution because it's not on the surface. So you just want to be careful. Like down here, you wouldn't add this hidden square in your surface area. You would only add the areas that are exposed. So for this one, it says find the surface area of the solid, round your answers to the nearest tenth of a square unit. Okay, so where do you think we're going to start?
Square?
Yeah, the cube down below. But instead of 6 faces, I'm going to do 5, exactly. Okay, so let's write down
So it's 8 times 5, which is 40.
area of cube
Oh, wait.
equals, how do I find the area of one of those squares?
4 times 4 is 16.
4 times 4, which is 16.
Times 5.
And then that times 5 exposed faces, which is?
80.
Okay, let's save that. We're going to add that in later. But next, we got to find the area of the pyramid.
Wait, that'd be 4 times 5 divided by 2, and then times by 4?
4 times 5, so that's the area of the triangle. 4 times 5 divided by 2. And then you said there's 4 of them.
Yeah.
Nice job.
So,
So like you said, 4
10
times
4.
5 divided by 2 is 20 divided by 2 is 10. And then you said we had 4 of those.
So it's 40.
40. Add those.
So it's 120.
120 what?
Centimeters squared.
Centimeters squared because it's surface area. Good work. Super easy if you know your formulas. Y'all just seem to know them really quick, so you spout them out. All right, down here, be careful. This one does not ask for surface area. This one asks for volume. So again, knowing those formulas is super helpful. All right, let's first find the volume of the cube. How do I do that?
3 times 3 times 2.
Very good. 3 times 3 times 3. Tell me what you get for that.
27.
Yep. Then we got to find the volume of the cylinder. Actually, it's a half cylinder. Huh. It's not even a full cylinder.
So we just divide by 2.
Yeah. So we're going to do our pi r squared, which is pi 1.5. Do y'all know where I got that from? Okay, good. And then, like you said, divide that in half. So punch that in. Tell me what you get for that so we can add that to the 27.
I got 353.25.
As the total answer or just
No,
for
that's
that
just
piece?
for the half cylinder.
So you did 1.5 times 1.5 times 3 times
Oh, I did
3.14.
314, not 3.4.
Oh.
Wait, let me try that again.
Okay.
I forgot to add a decimal number.
1.5 squared times.
4, 7,
Is it 10.59?
Yeah, I got 10.6.
10.6.
5 by 2.
So 10.6.
Yeah, that's what I got.
Perfect. So 27 plus 10.6. What's that?
137.6.
Mm-mm.
No, 37.6.
Oh, yeah, 37.6.
37.6 what?
Meters cubed.
Meters cubed. I love that you caught that because it's volume. Do you think you'd feel comfortable doing this or should I walk y'all through it?
What is that 1 yard thing?
So there's a cylinder within a cylinder.
Nope.
Nope.
Wait, do you just ignore that?
You don't ignore it.
You just have to find
You-
the area of, I mean, the,
Wait,
is it,
what's the area of the cylinder?
So
Well, yeah, no.
you're going to take the volume of this out of, so subtract it from the volume of this. Here, I'll do it with you because you guys don't feel
I don't
comfortable.
think I would.
Okay, so let's do volume of the large one. Remember, it's pi r squared. So we're going to do pi 5 squared, because that's the r of the large, times the height, which is 12.
I mean, 942.
942, is that what y'all got?
I'll do it too. Yeah, that's what I got.
942 even? Okay. And then the volume of the small, so pi 1 squared, 12 is the height. Tell me what y'all get for that.
37.68.
37.68. Now let's take the large number minus the small number. Perfect. That's what I got. 904.3. What do we label that?
Yards cubed.
Very good, because it's volume.
That wasn't as hard.
No, it wasn't bad at all. It just looked scary. Okay, last one. Jenna heats her home with propane, which is stored in a tank in her backyard. How many cubic feet? So that's code word. They didn't say surface area and they didn't say volume, but what should you gather from that language of cubic feet? Volume. How many cubic feet of propane does it take to fill the tank to the nearest tenth? So they want you to find the volume of this tank. So we already know that cylinders are pi r squared times the height. So that's how you would find the middle one. And we know that spheres are 4/3 pi r squared. Or is it pi r cubed? I think it's pi r cubed. Let me write that down for y'all. So volume of a cylinder is pi r squared height. Volume of a sphere is 4/3 pi r cubed. So now that I've given you these formulas, I want y'all to try it. Because that's the biggest battle, really. Y'all know how to plug and play.
Oh, it's gonna be easy. Just
So what's the radius for this
use 8 squared, which is 64.
4?
2.
The radius?
Okay.
Yeah, wait, the height would be 2, right?
The height is 8 and the radius is 2 of that cylinder.
So you do pi 2 squared times 4?
Pi 2 squared times 8
Oh.
for the cylinder.
So it'd be
Oh, because it's that.
Yes, you gotta
Okay.
rotate the paper.
Oh, I
8
don't like that.
times 8 times 4 times 3.14, which would get you 100.48 per cylinder.
Do you add them at the end? And then
Yes, correct. You add them together.
You do.
4
that's
over.
8.
Divided by
So
3. I don't know if that's right. So what that's
8 times 3.14.
Times, and then this one, the radius will be 4. For this one?
That one, so if we squish those two together, the radius would still be 2.
Okay.
Because the diameter is 4.
2 cubed is 16, right?
8.
8.
Oh, yeah, that's right.
you get like 134.
I got 33
For
point.
what?
The answer?
Wait,
Final answer?
33.5?
Correct. That's the final answer.
134? Yeah.
134 feet
Feet squared cubed.
33 point.
Wait, what
Calculator
you-
died,
what
so
you
let's
use
just
for
phone
that?
it.
Because I got that. So
Where do you get 25 from?
Is it 133 point?
That's the half thing.
134 is the final answer.
What is it to the nearest 10th?
Nearest 10th. Yeah, 1 decimal place. But I think ours came up pretty. Like it came up perfect.
Mine didn't. It's still 133. I got 133.98.
What are you
I
doing?
wonder if it matters too
3.14
whether we
times
use
2
the
times 8, and that is the area of the
Well, I
cylinder.
did.
The
round
key.
one of them.
Yeah.
Times
the
plus
button.
4
Because
times
what I did was I did it as
3.14
32
times 2
pi
times 2 times
plus
2
32,
divided by 3, and then
over
you get
3
134.
pi.
Just do the formula she gave you.
and then when I punched that in, because I left it as pi until the very end, and I got a perfect.
Well, for this, I didn't use all those numbers. I just made it to 5.
Oh, that's probably what
Yeah.
made it off just by a little bit. But like I've always told y'all, if you're even close to this, I'm taking it. So if you had like 133.1, you know what I mean?
Yeah, 0.1 feet.
Because it really does matter what we round to. So because I left mine as pi until the very end, that's why mine ended up with a pretty number. Okay, that's all there is for today.